Hi everyone, welcome to this new lecture, Fluid Mechanics. In this lecture, we'll discuss a new concept regarding Froude model law. In our last lecture, already we've discussed similar kind of one model law, that is Reynolds model law. And today we'll discuss about this Froude model law. So this is the law in which the model should be based on the Froude number. And we have discussed previously what is Froude number, and also we have discussed some other numbers also, dimensionless number. So Froude number is one of them, and the Froude number for model and prototype we need to consider, and that Froude number of model and Froude number of prototype should be same. So Froude number can be represented by FR, and this should be same for the model, and it should be same for the prototype also. So this need to be considered. Actually, we have already discussed previously what is Froude number. So Froude number also, like, it depends on the forces. There are different kind of forces. We already discussed previous lectures. So there I already told that Froude number is nothing but this is the inertia force to the gravity force. Okay, and here we need to similar things, like we need to the Froude number for the model, that should be equal similarity equal to Froude number for the prototype. And this concept, this Froude model law concept, can be applied in different places. Okay, the application will be in different places, such as I'll give some examples of this, and I can consider some free surfaces where the flows where the fluid is flowing over some spillways. Okay, some spillways is there, and I can say some kind of channels. We can consider some kind of channels, or any kind of where some kind of fluid flows will be there, that can be considered. Similarly, some other applications I'll tell. The flow of jet, when it is coming, we are calling as a flow of jet, when the fluid is coming with a high speed, so that time we can call as a flow of jet. So that is let me write this, flow of jet. So when the liquid will be in the jet form, when it will become with a high velocity, that means the velocity of the fluid will be very, very high. So that can be in the case of maybe in the case of nozzle, when the fluid is coming from the nozzle, or it can be considered for the orifice also. So this is one more. And similarly, when the wavy formations will be there in the surface, wave formations will be there in the surface, waves in the formed on surface. This is one more condition. And along with that also we can also consider where fluids are in the different densities. When densities are different, in flow one over another. So these are some applications of Froude model number, and as per the concept of this, we need to make it similarities between the model and the prototype. For that, as I told you, that we need to see here the Froude model number, Froude number. So or else we can type it, this is FE, suppose. So FE for the, I can write this is for the model, that is M, and similarly FE for the prototype, this is P. So this should be similar. We need to consider these things. Now, as I told you that we already have discussed this formula, we have derived already this formula, inertia force by the gravity force, I think. So in that we have also derived and we have found the equation of this Froude number, that is V by root over of G into L, V by root over of G into L. So V of model and G of model. Similarly, length of model. This equal to, again we can write this is Vp, again this is root over of, we can write again G of P and L of V. So what are these parameters? This is equation we got previously, not now. So this equation we can see in our previous lectures. So there we have derived this. And this one we can give a equation 1. So in this terminology, in this equation, you can see different terminologies are there. So what are the terminologies? So here I can write here this Vm equal to the velocity in the fluid in the model. So velocity of fluid, velocity of fluid in model. And similarly we can consider this is length Lm, linear dimension, or we can say length of model. And similarly one more is the Gm, this is gravity. Gm is the acceleration due to the gravity, of what? Of the fluid in that particular model. Similarly the other terminology will be there in the same we can consider, that is Vp and Lp and Gp is there. These are the similar conditions for the prototypes. Now as per this we can see the Gm and Gp, this both are gravity. So both are gravity that is going to operate at the model condition and the prototype condition. So the gravity is not going to different that much. So we can consider this Gm and equal to Gp, so that we can write in the further you can write this is Vm divided by root over of this Lm, and that equal to, we can write this is again Vp divided by root over of Lp. So this one again we can give, if you want to give an equation, we can give an equation 2. Again further we can write this, we will take this equation to the other side, and again we can write this is Vm divided by Vp, and again this term will also take it to this side like root over of Lp, and that one I can write 1 by root over of Lm by Lp, because here already Vm by Vp is there, so I can write Lm by Lp. So in the right hand side I can write this is 1. And again if you want to just convert this equation in terms of some other terminology, like take this to the other side, so I can write this is P by Vm equal to root over of Lp by Lm, so that we can get some ratio here actually. So this is nothing but this one we can write this is Lr. This one we can write Lr, because we know that Lp by Lm is the length ratio. This is scale ratio, or we can say length ratio. So root over we can give it here. So Lr is nothing but scale length ratio, or we can write length ratio. And similarly Vp by Vm also we can write this is Vr. So this Vp by Vm also we can write this is Vr, and that is the scale ratio for velocity, and this is scale ratio for length ratio, or I can say this is, we can write in this way, scale ratio for length. Okay, and similarly we can write this is that Vp by Vm also we can write in this way. So here we can write again this is Vp by, one more terminology I can write here, Vp by Vm equal to Vr, and this is nothing but scale ratio for velocity, and finally what we can write here in this equation, so Vp by Vm equal to Vr, and this equal to root over of Lr. So this is our final equation. Okay, now this is only one equation we have derived. Similarly, number of equations are there actually. This is the Froude number, model number. We have only derived on one ratio. So scale ratio for actually for physical quantities based on this model number, its number of models are there, number of ratios are there. This is for only 1 or 2 ratio we have identified here. Similarly, we can, based on this Froude number, actually the scale ratio for different physical quantities are different. So I'll tell first one example. Here I'll take one example for the Froude model number. One is scale ratio for time. One scale ratio we'll consider scale ratio. This is for time, scale ratio for time. So here we can consider this time. So time we can do what we can write. So I'll tell one thing. The velocity equal to, we know that distance by time. Velocity equal to, we can write this is distance by time. Now same thing if I write in terms of time, then what I can write is time equal to I can write distance by velocity. So distance means what? Distance means length. I can consider length by velocity. So again, I need to apply this Froude number in this conditions. So that means for the scale ratio for the time, I can write here TR. Suppose let me consider TR. So TR equal to what I can write? Now T of P, that means time for the prototype and time for the model. So this is time scale ratio for the time. So ratio equal to T time for the prototype, time for the model. Again here what I can write, as I told you here we are getting the equation of L by V. So similarly I can write here this is L by V for prototype and this is again L by V of model. L by V of model. So I can write again here LP by VP and similarly we can write this is LM by VM and similarly again we can write this is L by LP by LM and into this is VM by VP. So that will get, here we can get directly LR. Here we'll get directly LR because LP by LM is there. But here we will get VM by VP. VM by VP is there, that can be changed. So that one we can write in terms of VP by VM we got in the last this is. So this is the equation what we got previously. VP by VM equal to root over of LR. Now here we can write LP by MM, LM that is LR into, so we can write in this term, I'll reverse it, that means 1 by root over of LR. That I can write here. So if you see, if I multiply this one, this is L2 and this is like LR and this is 1 by root over of LR. So this is 1 by 2. If I take it to the numerator side, then I will get TR equal to root over of LR. So this is the equation, or this is the another one equation which we can highlight, equation number 4. So this is one scale ratio. I have taken an example for time. Similarly, many more are there. I'll give another one example, that is scale ratio for acceleration. Scale ratio for acceleration. So acceleration, we know that we can write in terms of like velocity by time. So I'll write this is V by suppose T. And the V by T, I can write this equation like, again, what is the velocity? Okay, we'll go again. So before that, let's write in ratio wise, like how we have written in the ratio. So same ratio we can write here, AR divided by this one, we can write AP. Acceleration of the prototype to the acceleration of the model. Okay, now again we need to find out acceleration of the prototype, what is the formula? Again, acceleration of the model, what is the formula? The same formula is there. So again we can write here V by T for the prototype. Similarly again V by T for the model. Like what we have done for this one, similar kind of things we can do for the others also. So again we can write this is AR equal to, finally we can write this is VPC, VP by TP, again VM by TM. So we can write VP by VM, again we can write this is this one TM by TP. So this is, we can write in this way. Again we can reframe this equation in different, like how we have done for the first one, like for the scale ratio time. So similarly this also can be converted and that can be written in this way. So we can write root over of LR. Again the same thing we are going to get here. Let's check it. So because VP by VM, we know that this is let's see that's what is the equation we got. See here, VP by VM, what we got, root over of LR. So here also same thing we kept. So now again just put this value here. This is root over of LR. Okay, and Tm by TP. Tm by TP is nothing but what is that? TR, time ratio. So same thing, we got what into root over TR. So LR. So again, I'll write this. This is LR. So acceleration equal to acceleration ratio equal to this one into this. So we can get that is nothing. Okay, sorry, this is TR. Sorry, TR, and here TR equal to TP by TM. Now here it is TM by TP is there. That means here we'll get actually 1 by root over of this. So finally we'll get acceleration ratio equal to, we'll get here 1. This is another equation. We can give equation number 5. Okay, so this one also we can make it in the box, highlight it. So this is the second one. Now few more are there. We'll discuss a few things. So let me consider another one. This is for, suppose I'll consider for the scale ratio for suppose discharge is there. So these are the small parameters we can consider, which is easy. Now in the scale ratio for the discharge, we know the discharge formula. So discharge formula equal to Q equal to, we know that A into V. So let's write Q equal to A into V, and this one in the place of area, let me write this is L square, length into length. So L square into, and this is velocity, we can write L by T, length by distance by time. So L by T. So this one we can write LQ by T. So this is our final formula. Now when you're coming to the ratio, this is only discharge. Now we'll go for the ratio. So ratio equal to, again we can write QR. So QR equal to, we can write the ratio of prototype to the ratio of model. That means discharge of prototype and discharge of model. So similarly QP, we can write the formula what we got here. Same thing we will just write. This is LQ by T. LQ by T for this is prototype, and similarly we can write this is LQ by T for the model. Now again we can write this one like LQP. So I'll write it directly. This is LQ for the prototype and divided by LQ for the model. Okay, this one divided by this into multiply with what we can do, TM type, and this is TP. Okay, now if you see here, this is LP by LM is nothing but length ratio, scale ratio for the length. So this one we can write LR, length ratio into like Q is there. Again this one TM by TP. Let's go back to the previous one. TM by TP, we got TP by TM, that is ratio, that is root over of LR. So here we got the value like TM by TP, that is nothing but 1 by LR, root over of LR. So this one also we can write, this is 1 by root over of LR, and this one we can write, if you take it to this above and if you solve it one, you'll get LR to the power 2.5. Okay, this is the answer. So this one we can give another one, equation 6. I hope previously we have given 5. Yeah, now this is 6. So this is another one, scale ratio. Similarly we'll solve another one, scale ratio for the force. Scale ratio for force. See why I have taken these are the properties. See time, this is the basic one, fundamental one. Okay, scale ratio for the time, this is the fundamental dimensions. Okay, and next is the scale ratio for the acceleration. This is coming under the like kinematic. And now in the next one we are discussing about the discharge and force. So this force is coming under the dynamic similarities. So everyone, like every aspects we will discuss one by one, so you can understand. So here in the force, I can write the force equal to, we know that, so I can write here. So force equal to, we know that mass into acceleration. Force equal to mass into acceleration. And this one we can write again. This one we know that we can write this is rho LQ. This one for the mass, because we know that mass equal to density equal to what? Density equal to mass by volume. So here mass I can write rho into V. Okay, So rho I have written, V I have written LQ, length into length into length, like length, breadth and width, so that I can write in this way. Again, if coming to the acceleration, that is velocity per time, that is V by T. And finally, if you write this, like again, this one we can split like rho L square into L by T into V. So what will get? Length by distance by time, that is velocity. So velocity into velocity, so that is velocity square. So we can write this is rho L square and V square. So this also we have discussed previously. To find out this value rho L square V square, just I have derived this one. Now again we'll go for the ratio. So ratio is nothing but FR equal to, we can write this is FP divided by FM. So force for the prototype and force to the model. Again, similarly, we can just put the value of this rho square, L square, V square divided by, this is for P and P and P. Similarly, again model, rho VM square and LM square. So again, this one we can write in terms of like rho P by rho M into LP, and this is LM whole square, let's write. Okay, again we can write the same thing, VP by VM whole square. Okay, so this is the equation now we got. Now here, if the fluid for the in the model and prototypes are same, then we can consider the density of the things is also same, because same fluid is there. So same fluid means density is not going to change until unless there is a huge temperature effect is there. So here again I can write this is here I can write this is force scale ratio, FR equal to, we can write this is LP and this is LM whole square into this is VP and by VM square. So here I can write this is rho P equal to rho M when the fluid is same. We are not considering some different fluids and there is no temperature effect that much. So it is not going to change. When fluid is same, even temperature effect also both are going to also act similarly. So now here again we'll put this value LP by LM, that is length ratio square. So we know that. So we'll put the value of LR. We got previously, so LR square. Again VP by VM, if you see previously we got some root over of LR actually. So let's see VP by VM. Yeah, VP by VM, how much we got? This is root over of LR. Okay, now just put the same value. So once you put here, V square is there. So that means LR square. So here we can write this is LR square into LR. So this is LR cube. Equation 7. Now the next one we'll see the scale ratio for pressure intensity. So this is another part. Now in this again we know that pressure equal to force by area. Pressure equal to force by area. So we can write here force equal to, just now we got rho L square V square divided by area. Area also L square you can write, and this is nothing but our P. And finally we can write P equal to, just to cancel this L square you can cancel rho V square. So this is pressure again, but we require a pressure ratio. So what I'll do here, I'll just write pressure ratio, that is PR. So PR equal to, I can write this is PP and divided by PM. So similarly we can write this is rho P and this is VP square, and similarly here rho M and VM square. And finally again if you consider that rho P and rho M equal to same, then we can write this is PR equal to VP square and divided by VM square, which is nothing but LR. So VP by VM square, let's check it once. VP by VM, now root over of LR. If you take the square, so square root will be cancelled, so we'll get the LR. So this is another one equation. equation number 8. So this is another one ratio, that is pressure ratio, scale ratio. Now the last one we'll discuss, that is scale ratio for the power. Scale ratio for power. Okay. So now here for this power we can write, we know that power equal to, we can write this is work done per time. Work done per time. So work done equal to, again we can write, actually before power we can discuss some about like work, energy, torque, distance, momentum, like these are things also can be discussed. So that also will be same ratio we can calculate. Let's see for the power. In the power we'll write like work per unit time. That one you can write again force into this is length per T. For F into L by T we can write. Now again power ratio equal to what we can write? Power ratio equal to power of the prototype and power of the model. So similarly we can write this is FP into LP divided by TP. Similar manner. Again here we can write this is FM into LM divided by TM. So this is the process. Similarly we can write this is FP by FM, again LP by LM, and this one I'll write 1 by TP by TM. Okay, and finally we can write this is PR equal to, we can write this FP by M, that one we can write FR, so scale ratio, that is force ratio, into LR, that length ratio, and 1 by PR, this is ratio. So these are the things. Now again we can write this one like FR equal to, we got previously LRQ. FR force ratio we got just now. If you see, this is the answer we got. So FR the force ratio equal to LRQ, again LR equal, again LR we can write this one LR, and this one 1 by root over of LR. So finally if you solve, you'll get the power ratio, the scale ratio for the power PR equal to L to the power 3 by 5. And this one again we can give equation 9. So this is all about the ratios, all of the ratios of different parameters. So I hope you understand this Froude model law. There is nothing difficult, very simple. And still if you are having any kind of doubt regarding this, you can give a comment on the comment box. Thank you.